Welcome back to chapter 25. This will be the third section on it. In this, we're going to begin our study of spherical mirrors. Okay, so first off, we're going to look at a simulation to get us oriented. I have that simulation already pulled up because it doesn't work in Google Chrome. I have to look at it in Internet Explorer because it is a Java simulation. So here we have a object. I always think of this maybe as a person with an green body and an orange head or peach head. And the light comes in, hits the mirror, follows the law of reflection, and reflects out. Okay, so this would be a concave mirror because it is looks like the input to a cave for the object, if you will. Okay. On the other hand, I can flip this guy around and this would be a convex mirror. Okay. So let's see what types of reflections we can get here with our concave mirror. So the first thing I'm going to do is I'm going to start by moving our object away from the mirror as far as I can. So it's off screen at the moment, but that's okay. Okay. There are 2 points that are important when we're looking at a mirror. One is the center of curvature. If this mirror were a complete circle or a complete sphere, that C, sometimes written as R sub C, would be at the center of that. The focal point is at half that location. So right now our rays come in from really, really far away. One is reflecting through the focal point. The other one is going in and out from the center. And we can see we have an image that occurs between the center of curvature and the focal point. And it is smaller than our object. Remember, our object comes up to this line. And it's also upside down, if you remember. Okay. So let's bring that object back in. As I bring the object back in, the image is getting bigger and bigger and bigger and bigger until I hit the center of curvature. And now if you look, it's the exact same size as the object. And as I bring the object in further, now the image is bigger, but it is still upside down. Okay. And that keeps occurring until I hit the focal point. Now, right before the focal point, every image you've seen so far has been a real image. I could put a sheet of paper on this half so that I'm not blocking the light coming in from the object, and you could see the image on that paper if you put it at the correct spot. It is a real image. But when I move the object in past the focal point, my image is now on the other side. I can't put a screen behind a mirror. The mirror is in the way. Therefore, I now have a virtual image. Okay, so summarizing. With a concave mirror, I can get a real, inverted, smaller image. I can get a real, inverted, larger image. Or I can get a virtual image, and notice it is upright, so it's going on the same side of the central line. And it is bigger. So it's virtual, it's upright, and bigger, or you might say magnified. Okay. Now let's move our object back out and flip our mirror around again. So here we are. Now I have a convex mirror. I'm going to do the same thing. I can see my image right up here. It is currently virtual. It's behind the mirror. It's on the other side of the mirror from the object. It is upright and it is smaller. And as I move the object in, the image gets bigger, but it always remains virtual, upright, and smaller than the object. Okay. So that's what we're going to look at. To illustrate this, physicists often draw these things called ray diagrams. So the next few slides, I'm going to go through the ray diagrams. In class, I would draw these by hand, but it is really, really hard, virtually impossible to draw these by hand when using the tablet, because I can't see where I'm drawing. I have no basis here. So I'm sorry, you're going to get animations. Okay, when doing ray diagrams for a mirror, you use the same 3 rays. The way those 3 rays might look will change, but they have the same definitions. Okay, so first off, notice what I have is I have my mirror down here. I've defined 2 points. One is the focal point, and the other one is the center of curvature. Remember the simulation, this was labeled as a C. Here I call it RC. Remember, if this mirror were a full circle, RC would be at the center of that circle. Okay. If you want to draw a good ray diagram, you need to make sure that your focal point is halfway between the center of curvature point and the mirror. That is a true statement. The focal point is half the radius of curvature. Okay. I've also got my object over here, which I've represented its location with the letter D sub O for object. And I'm just going to use an arrow. Okay, so what do these 3 rays look like? The first one, I'm going to always draw in red. It comes in parallel to the central line known as the axis. Okay, in parallel. And then it hits the mirror and it reflects through the focal point. Okay. The blue one comes in, it also hits the top of the object, and on its way in it hits the focal point, and then it reflects off parallel to the axis. The red ray and the blue ray are almost opposite of each other. The red one comes in parallel across the top of the object and reflects through the focal point. The blue one comes in, hits the top of the object and the focal point, and then reflects parallel. And lastly, the green ray is going to just go in and out along the center of curvature. And notice there's a point here where the 3 outgoing rays overlap, and that is the location of the image. Okay, so if I were to characterize this image, I would say that it is a real image, because I could put a screen and put that arrow onto a screen. So I would say it is real. This arrow points up, that arrow points down, therefore it is inverted. And this arrow is taller than that arrow, therefore the image is smaller. You might also hear me say that it is diminished. Can't spell today. Diminished. Okay. For the next ray diagram. Okay, so same 3 rays. All I've done here is I've moved the object inward. Okay, so now the object is between the center of curvature and the focal point. Okay, so the red ray, green came in first. Not sure why. So there's green. That one, remember, goes across the top of the object and through the center of curvature. The red ray comes in parallel to the axis and then reflects through the focal point, but it has to hit the top of the object. Don't forget about that. And the blue one hits the top of the object on its way in, also hits the focal point, and then reflects out parallel. The 3 reflected rays meet over here, and that is where the image is. Now, one thing I will say at this point, I worked really hard to get very pretty ray diagrams for this. It is difficult to get ray diagrams where your 3 outgoing rays meet at a single point if you're drawing them by hand. You have to be very careful. You have to measure everything. You should draw the mirror with a compass. Okay. Oftentimes, instead of getting this, what you'll get is you'll get your 3 rays, and they do something where you get kind of this little triangle, or even maybe a bigger triangle. That's okay, as long as you identify wherever, or the region in which they cross as being where the image is. Okay. So enough with that aside. Characterizing this image. Again, I could put a screen here. So it is real. It is inverted. My 2 arrows, one points up, one points down. And my image is bigger than my object arrow. Therefore, you can say it is bigger, or you'll often hear me refer to it as magnified. Okay. Okay. One more for the concave mirror set. For the concave mirror set, this time I've moved the object forward again, but you can also see that I moved everything to the left because I'm going to need to be able to use the area behind the mirror in this case. Okay, so same 3 rays. Same 3 rays. Oh, blue first this time. So the blue ray, it now comes in like this because it's got to go through the focal point and hit the top of the object. And the only way I can draw that line is by going in at this angle. It hits the mirror and reflects out parallel. The red ray comes in parallel, hits the top of the object, hits the mirror, reflects through the focal point. And the green ray, again, top of the object and the center of curvature, in and out on the same line. Now, if you look at your 3 outgoing rays, you see that in front of the mirror, on the same side as the object, they do not cross. Therefore, I do not get a real image. So I have to go looking for my virtual image. And to find the virtual image, I take the 3 outgoing rays, the one that I've circled there, and extend them backwards. So that looks like this. See, the blue ray extends backwards like this. The red outgoing ray extends backwards along this, and the green one follows the same line. And those 3 cross here. So that's where our image is. But it's now behind the mirror, therefore it's virtual. Both arrows now point upward, so this image is upright. And if I compare the size of my object to my image is bigger. And again, often that is referred to as magnified. Okay. Now, on to the convex mirror. For the convex mirror, the mirror now focuses or faces the other direction. And remember, if this were a full circle, this RC point would be at the center of the circle. So that's got to be on the opposite side of the mirror from where my object is. Okay. But it's still the same 3 rays. I've just got to draw them a little bit differently. So the red one comes in parallel to the axis, and then the outgoing ray connects where the incoming ray hits the mirror and the focal point. And then it goes out. The blue one, remember that one has to come in, hit the top of the object, and hit the focal point. So that looks like this. And then it has to reflect out parallel. And lastly, the green one goes in and out through the radius of curvature, or the center of curvature. So I have to hit the top of the object, and I have to hit RC. And again, if I compare my 3 outgoing rays, they don't cross in front of the mirror. Therefore, I cannot get a real image, and this must be a virtual image. Because it's virtual, I got to go looking for the image again. And so I take my 3 outgoing rays, and I back them up. Notice there are 2 blue rays, but I want the one that follows the outgoing ray. So I want this one, not that one. Those 3 outgoing rays cross right here. So that is where my image is. Okay. Looking at that image, we've already said that it's virtual. Both arrows point up, so it is upright. And my object is bigger than my image, therefore my image is smaller, which often is referred to as diminished. Notice I spelled it right this time. So summarizing all of that, for a concave mirror, I can get 3 types of images, and it's all about where is the object relative to those 2 important points in the 2 important points of the mirror. So if it's out beyond the center of curvature, the image I get will be real, inverted, and diminished. If it's between the center of curvature and the focal point, then it's real, inverted, and enlarged, or magnified, or bigger. I have all sorts of words going here. And if it's in between the mirror and the focal point, then the image is virtual, upright, and enlarged. For convex mirrors, no matter where I put the object, I only can get one type of image, and that is virtual, upright, and diminished. Okay. The next section, we're going to go through the math to calculate exactly what we've just done schematically.